Alright, so in this problem, I have 0.01 to the power of x is equal to 2. So I want to find the value of x here. So for my solution, first start with 0.01 to the power of x is equal to 2. Now I'm going to take the log on both sides. So now I have log 0.01 to the power of x is equal to log 2. Now, if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this would equal b times log a. So in this case, I have log 0.01 to the power of x, and I can simply move x to the front. So that's going to equal x times log 0.01 is equal to log 2. Now 0.01 is the same thing as 1 over 100. So now I have x times log 1 over 100 is equal to log 2. Now if I have something in the form log a over b, this is equal to log a minus log b. So in this case, I have log 1 over 100. I can rewrite this as log x times log 1 minus log 100. This is equal to log 2. So now, log 1 simply equal to 0, and log 100 is simply equal to 2. So I have x times 0 minus 2 is equal to log 2. That's equal to approximately 0.301. Now 0 minus 2 is negative 2, so I have negative 2 times x is equal to 0.301. And now I'm going to go ahead and divide both sides by negative 2. So these two cancel out, and I'm left with x is equal to 0.301 over negative 2, which is equal to negative 0.1505. So this is my answer. Alright guys, in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So to solve this, what I'm first going to do is I'm going to factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times, now 3 to the power of x divided by 3 to the power of x, that's simply 1. So I have 1 plus, again, it's the same thing, 1 plus, final time, the same thing, and this is equal to 333. Now, if I add what's in the parentheses, I get 3. So now I have 3 to the power of x times 3 is equal to 333. So now I obviously want to isolate 3 to the power of x because this is the term that has the variable x that we're solving for. So I want to try to find a way to get rid of this 3. So to do that, I'm going to divide both sides by 3. Now, these two 3's simply cancel out, and I'll be left with 3 to the power of x is equal to 333 divided by 3, which is 111. So now I got this equation, 3 to the power of x is equal to 111. So to solve this, what I'm going to do is I'm going to take the log on both sides. So now I have log 3 to the power of x is equal to log 111. So now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So for log 3 to the power of x, I can move x to the front. So now that would lead to me having x times log 3 is equal to log 111. So now what I'm going to do is I'm going to divide both sides by log 3. So then for my left-hand side, these two log 3's simply cancel out, and I'll be left with x is equal to log 111 over log 3. So now, if I have something in the form log a over log b, this is simply equal to log base b of a. So in this case, I have log 111 over log 3, and I can write this as log base 3 of 111. So this is my answer. All right, so in this problem, I have 2 to the power of 22 minus 2 to the power of 21 is equal to 8 to the power of x. So I know at first glance, this problem looks pretty complicated. However, it's actually easier than you might think it is. So for this problem, I'm solving for the value of x. So for my solution, first start with 2 to the power of 22 minus 2 to the power of 21 is equal to 8 to the power of x. Now, it's 22 here. This is the same thing as 21 plus 1. So I'm going to rewrite this as 2 to the power of 21 plus 1 minus 2 to the power of 21 is equal to 8 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 21 plus 1, I can rewrite it as 2 to the power of 21 times 2 to the power of 1. And I still have minus 2 to the power of 21 is equal to 8 to the power of x. And now, from here, 8, that's the same thing as 2 to the power of 3. So now I have 2 to the power of 21 times 2 to the power of 1 minus 2 to the power of 21 is equal to 2 to the power of 3 to the power of x. Now, for my left-hand side, if I factor out 2 to the power of 21, I get 2 to the power of 21 times 2 to the power of 1 minus 1. This is still equal to 2 to the power of 3 to the power of x. Now 2 to the power of 1, that's equal to 2, and 2 minus 1 is 1. So I'm left with 2 to the power of 21 times 1 is equal to 2 to the power of 3 to the power of x. Now anything times 1, it's simply itself, so 2 to the power of 21 times 1 is simply 2 to the power of 21. So I have 2 to the power of 21 times 2, is equal to 2 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x, that's going to equal 2 to the power of 3 times x. So I have 2 to the power of 21 is equal to 2 to the power of 3x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 21 is equal to 3x. So I have 21 is equal to 3x. All I have to do to solve this is simply divide both sides by 3. These two cancel out, and I'll be left with x is equal to 21 divided by 3, which is simply 7. So x equals 7 is my answer. All right, so in this equation, I have x to the power of 4 plus x squared is equal to 20. So to solve this, what I'm going to do is first start by subtracting 20 on both sides, so we can have all our terms on one side. So I get x to the power of 4 plus x squared minus 20 is equal to 0. Now this may seem like a quadratic equation, but it's not, because we have the power of 4 as our primary term, and then that's led by the power of 2. And in a normal quadratic equation, we have 2 as our primary, then we just have 1, and then we have some constant c. So how are we going to solve this? Well, we can't factor this out by using the quadratic formula because this is not a quadratic equation. So to solve this, what I want to do is rewrite this as x to the power 4 plus x squared minus 16 plus 4. So I rewrote 20 as 16 plus 4. And the reason I did this is because negative 16 is the same thing as negative 2 to the power 4, and negative 4 is the same thing as negative 2 squared. So now notice how I have something in the power of 4 and something in the power of 2, and they're both the same. Now I can put the powers of 4's together and the powers of 2 together. So I get x to the power 4 minus 2 to the power 4 plus x squared minus 2 squared is equal to 0. Now 2 to the power 4 is 16, and 16 is the same thing as 4 squared as well. So I get x to the power 4 minus 4 squared. And I have this plus x squared minus 2 squared. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 is the same thing as x to the power of 2 times 2, which is equal to x to the power of 2 to the power of 2. So now I get x to the power of 2 to the power of 2 minus 4 to the power of 2 plus x squared minus 2 squared is equal to 0. Now notice how everything is in the power of 2, and if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So we're going to use this property on these two groups. So I first get x squared plus 4 times x squared minus 4 plus x plus 2 times x minus 2 is equal to 0. Now we can use this property again on x squared minus 4 by rewriting as x squared minus 2 squared. So that's going to equal x plus 2 times x minus 2. And I have this plus x plus 2 times x minus 2 is equal to 0. Now I'm going to factor out x minus 2, so I get x minus 2 times x squared plus 4 times x plus 2 plus x plus 2, which is equal to 0. And notice how we can also factor out x plus 2 as well. So actually at the start what we could have done is just factored x squared minus 4 out, but now we're going to factor out x plus 2 as well. So I get x plus 2 times x minus 2 times x squared plus 4 plus 1 is equal to 0. So x plus 2 times x minus 2, like I said, was x squared minus 4. And I have this times x squared plus 4 plus 1, which is x squared plus 5. Now this is equal to 0. Now this gives me two equations. I get x squared minus 4 is equal to 0, and I get x squared plus 5 is equal to 0. So for x squared minus 4 equals 0, I can add 4 on both sides. So I get x squared is equal to 4, and this is equal to positive or negative 2. And for x squared plus 5 is equal to 0, I get x squared is equal to negative 5, and I get x is equal to positive negative square root of negative 5, which is equal to positive negative square root of 5i.